Stream deposition, deposition of sediments by streams. Let's go. So you have deposition here, where this river flows into the ocean. In this case, that's the mouth of the stream, and that's where you have a lot of deposition. The thing that you often get forming in the area is called a delta. In this area, you get a delta because the water comes down here, and the water's moving the sediment along, hits the ocean, the water speed really slows down, and then the sediments just get dropped right there and deposited right there. So here, this was a diagram from a Erosion exam. Here's the Gulf of Mexico, Mississippi River. I'm going to outline a section of the delta here, and you can see all the gray is the land, and that's what it does. It basically deposits a lot of sediment. In this case, it could actually make some land on big enough rivers. And this shows a 3 steps in the formation of a delta, also from a Erosion exam. So here you have the river flowing in. You see some sediment building up. Many years later, you have more built up here, and even many years later, you have a lot more of this. All of this black, which is new sort of land or sediment, is all been deposited since this. And so what you see is where you have a mouth of a stream flowing into an ocean or even a big lake, you have this kind of pattern. Larger sediments here, and as you move further out, the sediments get smaller and smaller. It's called horizontal sorting, and that's the nature of sort of how sediments settle in water. Now I'm going to show this video that I took of a demonstration in class showing how the size difference of sediments affect how they settle. Let's check it out. Okay, here I have mixed sediments, pebbles, sand, silt, a cup of it here, trusty funnel. Watch this. Dump them all in at once and all right, that video is cool. I went back the next day and let it really settle, and here's a picture of it. And what you get is larger pebbles down here. As you have to get smaller and smaller and smaller and smaller, and then you have like large sand, fine sand, and you can even see the silt here is like a different color, it's a little browner, so that's a really fine silt, and some of it is even kind of still settling out here. So you have larger to smaller, and that's because the larger particles will settle through water faster than the smaller particles. Okay, that's important. So another way that they show it is the stream ocean surface. They're just showing it here with the terms. They have pebbles here, sand, silt, and clay. That's important. And here, I like to show it this way because you have a rock here the size of a bowling ball barely getting pushed along the bottom of the stream. It goes here, it just stops. And if you think of the sand, let's say, that goes out here will settle faster. Sand may settle here. The silt will get carried all the way out. And it may take days, weeks, months to settle really, really, really fine sediment. So this is this sort of sorted or pattern or order to the deposition from a stream. Important. Okay, what is a depositional feature at sea? What's it called? This was a question. Answer, delta. Sometimes the question is this: why does it form? Why does the delta form here? What's the cause of it? And it's really because the water slows when the river reaches the ocean, and that causes deposition. The sediments are deposited because of this slowing water. Okay, so I really want you to understand that. That's important. Not a lot on the reference table on streams except for this. This is on page 6 of the reference table. It has stream velocity, speed of the stream, and the size of the particle it can move. Obviously, the faster the water goes, the more force, the bigger the sediment it can move. A stream flowing 1 mile an hour can't move a rock this big. Not enough force, but maybe a stream going, 20 miles an hour has that force. So, but this is in centimeters per second, so let's just go through this. So here's the type of question you may get with this is, hopefully you can read this. I'm not sure if you can here. I'm going to make it bigger. The minimum stream velocity necessary to transport a sediment particle that is 0.1 centimeter in diameter is closest to. These are your choices. So you have to know to go to the reference table. You're not going to know this out of your head. If you don't use the reference table, it is a random guess. We don't want to do that. So basically, it is 0.1 centimeter in diameter. Here's the diameter. I want to go over to here. Okay, to this line. This line is what gives us the information. Then I draw a line down that way, and the answer is about 5 centimeters per second. Therefore, I look at my choices here, and actually the closest one is 5.5 centimeters per second. So that's how you'd answer that one. Let's do another one. This is a different question, and let's zoom in on this as well. So, what is the name of the largest sediment that can be transported by a stream moving at a velocity of 100 centimeters per second? And it's silt, sand, pebbles, cobbles. So, let's go here. What you want to do is 100 centimeters per second is down here. So, I'll follow it up to the line. And I don't really need to know the size. I need to know the name of the sediment. These are the names. So, if you notice, it's right here. It falls into the category of pebbles. Okay, because this size is in the pebble range. So, the answer here is pebbles. And that's just two examples of using this chart, but you have to know that this chart is there, and so to get a sense of how to use it.